Today we're going to take a look at translations and rotations, two different types of transformations that we can do to different figures. And we're going to take a look at them mostly on the coordinate plane. At the end, we're going to take a look at how we could do this perhaps off. So we had talked last time about rigid motions. Rigid motions preserve size and shape. And when we said size, we meant side length, the length of the sides, and the angle measures. And a translation is a type of rigid motion. And it's a motion where everything is moved in the same direction and the same amount. So if we take a look, triangle ABC has been translated to its image, A prime, B prime, C prime. So remember, we had called this the pre-image. And the final would be considered the image. And we're trying to figure out how we would translate from triangle ABC, the pre-image, to the image. So we are going to take a look, since I'm moving everything in the same direction. We want to count how far over have I moved this point and how far down have I moved this point. So if we count in the left direction, I can see that I have moved this left 8 units, and I have to move this down a total of 4 units. And if I look at all of our other points, we can see the same thing. If I count from C all the way over to C prime, again, that's moving it 8 units to the left, and then I would have to move it down 4. So we could describe this, we could put this into words, we could say left 8 and then down 4. And then we can put this in different types of notation, and you're going to see this a couple of ways, expressed in a couple of ways. One way you'll see this expressed is with this capital T. Anytime you see a capital T, that stands for a translation. And it has a little subscript on the bottom. And that subscript, it's in the coordinate order x comma y, and it tells you how to move the coordinates and how much. And typically you'll see the actual point that you're moving, or sometimes they give you the general form x comma y. So that's maybe one way that you'd see this notation. Another way that you would see this notation, perhaps, is that you could see something that looks like x minus 8 and then y plus 4. So just telling you I have to move my x coordinate to the left 8 units and the y coordinate 4. So it says, what has been preserved under this translation? Well, knowing that it's a rigid motion, we can say the size. And again, anytime we talk size, two things that we want to think about. It's the length of the sides, but also the angle measure. Okay. And then this is a new one. It says, is the order of the vertices the same? So this order is called orientation. So if we go back up to this picture, we want to take a look at how the triangle is labeled. So if I start at our pre-image and I go in this counterclockwise direction, I can see that this triangle would be labeled A, then B, and then C. So I want to see, is the order the same? So I want to start at that same location on the image. So I would start at A prime, and I would go in that same direction, that same counterclockwise direction to test it. So I would go from A prime, I would hit then B prime and C prime. So I can see the order is the same, or the orientation is the same. So down here, is the order of the vertices the same? Yes. Okay. So what we have just found is what's called a direct isometry. Isometry and rigid motion are pretty much the same thing, meaning they preserve the size and the shape. But because it's a direct isometry, and this is the difference, it preserves the orientation or the order of the vertices, kind of like what we saw above. An opposite isometry, or an opposite, we can think of it as a rigid motion, preserves the size, but the orientation, or again, you could say the order, of the vertices change. So we just said, what type of a translation, or what type of an isometry is a translation? Well, this is a direct. The order does not change. Now a reflection. So let's draw an example and let's see what this would look like. So let's say that this is triangle A, B, C, and I want to reflect it over this line. Well, once we reflect it over this line, my new picture, this is going to be A prime, here's C prime, and here's B prime. So if we do the same thing like we did up above, start at your pre-image, pick a point. So I'm going to pick A, and I'm going to go in that counterclockwise motion. So I have my triangle ABC. So I want to do the same thing on my image. I'm going to start at A prime and go in that same counterclockwise motion, but notice what happens this time. We go from A prime to C prime to B prime. So in this case, I can see the order of the letters or the orientation has changed, which would mean this would be an opposite isometry. Okay, so our translation rule. So we kind of looked at this up above. So here's your general form of the translation rule. So I have my T for translation. This is telling me how much I'm moving my X, how much I'm moving my Y. So that means in the end, I would have X plus whatever the A value is, comma Y plus whatever the B value is. So I'm always thinking of translations in terms of adding. So it says we're going to write a rule to describe a translation, 4 units to the right and 6 units down. So if I'm going 4 units to the right, I know that I'm moving in the positive direction 4 units. If I'm going to go 6 units down, that means I'm moving in the negative direction, negative Y direction, 6 units. So if I were to write this as a rule, capital T, I have positive 4 for my X, I have a negative 6 for the Y, and it's on our coordinate. And so what this would say then is to my X value, I would add on 4, and to my Y value, I could think of this as adding on a negative 6, that's an option. Okay. Or typically you will just see it written as subtracting 6. Okay, so let's try some of these. So we have our coordinates and we have to find the image of our figure under this rule. So here's a different way to see it. Now, no capital T, but they're telling you what to do. To the X values, add 3. To the Y values, add 2. So if we start with A, I know to the X value, I want to add 3. And to the Y value, I want to add 2. So that means our new image point is going to be at the location 2, 4. So that would have done that translation. Okay, we try it again for B. So B, we're starting off at negative 9, 3. And I want to do this translation. So at negative 9, I'm adding on 3. To my Y value of 3, I'm adding on 2. So when we simplify, negative 9 plus 3, we get a negative 6. Positive 3 plus 2, we get 5. And one more, if we start with C, I see that our C value is negative 6, negative 1. So to our negative 6, I'm adding 3. To negative 1, I'm adding 2. So our new location, once we add negative 6 plus 3, we're going to have a negative 3. And negative 1 plus 2, we have a positive 1. So our translations, we're always thinking in terms of adding. Now we get to rotations. Now here's a little bit different. So on all of these figures that we see here, we're going to do different rotations, 90, 180, 270, and 360. And the nice thing is when you're doing this, you can actually physically turn your paper. Now, I can't do this on the board, but I'm going to ask you as you're following along, turn your paper and watch what happens. And when you're doing the rotation, the rotations are always going to go counterclockwise, so in that direction, so down to the left, unless it's stated otherwise. So we have a rotation of 90 degrees, and these are all centered at the origin. So again, centered at the origin, going counterclockwise unless stated otherwise. So I'd like you to physically turn your paper down to the left and see what happens. And when you turn your paper down to the left, now I want you to look at that set of axes and I want you to see where is my point located. And you're going to see when you turn it, now you're going to just read it like you would a regular graph. You can see you have to go to the left 2 units, so that's a negative 2. And you see that you have to count up 4 units, so that's a positive 4. So now flip your paper back. And we can actually plot that. I can go -2, +4, and I can tell you that that's going to be our point. So if this was A, here's A prime after a 90-degree rotation. Okay, 180. So you're turning your paper upside down completely. And again, same idea. So turn it upside down, take a look at the graph, and see how am I going to plot that point. So you would be going to the left 4 units, and you'd be going down 2 units. So if you turn your paper back, and now we're going to plot that. So I'm going to go -4, and then I'm going to go -2, and I can see that again, if this was our A coordinate, this is my A prime, that's my image after a rotation of 180. Rotation of 270, so now that's 3 turns. So if you turn your paper counterclockwise, 1, 2, 3 90-degree turns, and reread it, I can see I'm going over a +2, and then I have to go down -4. If you turn it back, we can plot that. So I can go +2, -4, and again, here is my new image after we just rotated that pre-image point 270 degrees. Now, rotation of 360, that's 4 90-degree rotations. If you rotate something 4 times 90, that's 360. It's going to bring you right back to the start. So a 360-degree rotation really doesn't do anything to your coordinate. Okay, so maybe some simple rules that we can write down. When you do a 90-degree rotation, if you take a look at the coordinate up above, it looks like we took the point, we flipped the order, and whatever was in the y position was negated. X stayed positive, right? So to begin with, 4 was positive, it stays positive. The 2, our y value, now becomes negative. When we do a 180-degree rotation, it looks like our coordinates, well, they didn't change order, but they both changed from positives to negatives. And for our last one, the order changed, and then what also happened was y stayed the same, but our x values negated. So these are nice little rules if you commit them to memory. It does make doing rotations a little bit faster. You can always turn your paper and graph, but those rules do kind of help out. So we're going to try a 90-degree rotation here on triangle DEF. And maybe to get us going, let's write down our original coordinates. So D is at -7, -2. E is at -2, -3. And F is at -2, -7. So keeping in mind a 90-degree rotation, and notice our symbols that we're getting up above. So capital R for rotation, 90 degrees is that second number. The O standing for origin, that's where your center of rotation is. So our 90-degree rotation, we start with a coordinate, and when we're done, we said we'd flip the order and negate whatever was y, or change the sign. So if I start with D, I want to flip the order, and I want to negate whatever was our y coordinate. So that's our y coordinate. I want to think negate it. Opposite of -2, +2. And then my x value just becomes my y value. And for letter E. So again, I'm taking my y coordinate, that becomes my x coordinate, but it becomes the opposite sign. So it becomes a +3, and then the y just stays y, but moves. Okay, and lastly, I take that -7, take opposite sign, that becomes my x value, so now that's a +7, and my -2, I keep the sign, it just goes into that y position. Okay, so those are rotations. Now, off the coordinate plane, meaning not on an axis, we can also do a rotation. And we're going to do this using a compass and a straight edge, and there's steps on the bottom. And it says, in order to find our center of rotation, we are going to construct first the perpendicular bisector of segment AA prime. Meaning, what we want to do is we want to get a nice straight line from A to A prime, and with our compass and straight edge, we're going to bisect that. Then we're going to do the same thing going from B to B prime. Okay, so first thing that we're going to do is we got to get our compass. And when you're doing a perpendicular bisector, we want to think, take your compass, open it as wide as the segment, and what we're going to do is, it can go about as wide as the segment. We said it had to be a little bit more than halfway. Once we get that, we're going to make an arc top and bottom. We're going to flip it around. We're going to do the same thing from that other end point and make your arc top and bottom. And then with a straight edge, you're going to connect those 2 points. And we're going to see we've now bisected the segment. Okay. We're going to do the same thing this time. We're going to move it over to segment BB prime. And again, when we do this, we want it to be a little bit more than halfway. It could be the full entire segment length. And we are going to bisect segment BB prime. So flip it around, do the same thing from the other end point all the way over to B prime. And we're going to bisect it. And again, with a straight edge, what we want to do is connect our intersections. So we're going from here, oops, all the way over to there. I got a little messed up. But what I can see, here's the important part, is I can see that our perpendicular bisector, if I extended it down, would intersect right there. So what we have just found, that's that point P, that's your center of rotation, and that's what you're looking for. So we're going to do more with this in class. This is just to get you a foundation, and hopefully this helped. And don't forget, like and subscribe. Have a great day.